and that's balanced by the centripetal forces pushing inwards. Now this is all fine and good, but what if the disk is bumped so that it's no longer rotating perfectly about the y-axis? Well, now the small masses will experience some centrifugal force proportional to their distance from the y-axis. Tension forces within the disk ensure that these small masses remain orthogonal to the big masses, and since the big masses are still spinning in roughly the same positions as they were before with they constrain the small masses to lie more or less in the yz plane. The little centrifugal forces on these small masses start accelerating them, and those forces get bigger as the masses move further and further from the y-axis, and they keep accelerating until they flip onto opposite sides. Now for the first half of this flip, the centrifugal forces are accelerating the small masses, but in the second half, the centrifugal forces slow the masses down, reversing all the previous acceleration, so that they basically come to rest when they reach the opposite side. The pattern then repeats indefinitely, with the disk flipping back and forth at regular intervals. And there you have it, an intuitive explanation for the intermediate axis theorem, or tennis racket theorem, or Janabekov effect, or whatever you want to call it. So if this is well-established classical physics, why did the Soviets make it classified for 10 years? Well, possibly because of what Janabekov did after observing the strange behavior of the wingnut. He attached a ball of modeling clay or plasticine to it and tried spinning that. And sure enough, he found that just like the wingnut, this ball flipped over periodically. And the implication was that maybe since the Earth is a spinning ball in space, it too could flip over. I mean, we know the Earth's magnetic poles have reversed in the past, so could this be related? In 2012, with the Mayan prophecies of the end of the world, speculation about the Janabekov effect proved irresistible for some conspiracy theorists and people in the media. Plus, on May 13th, 2012, the official site of the Russian Federal Space Agency, Roscosmos, posted an article in honor of Janabekov's 70th birthday. And in it, they said, "The spinning nut of Janabekov caused astonishment and simultaneous danger to a certain part of the scientific world. A hypothesis was proposed that our planet, in the course of its orbital motion, can execute the same overturn." So, how do we assess the validity of this hypothesis? I mean, is the Earth actually going to flip over? Well, we can get some clues from simple experiments performed by astronaut Don Pettit aboard the space station. He shows that a book will spin stably about its first or third axis, just as we'd expect, and a solid cylinder will also spin stably around its first or third axis.